All right, moving on to the next part of the question. In part B, we're basically just given 7 different configuration of tree states, and then we just want to decide whether or not it is possible to generate each one of these configuration using quick union and weighted quick union. So if we look at part A first for quick union, basically every single one of these tree states should be able to be generated, right? Because in quick union, we do not care about the size of the component when we connect them. So as a sanity check, let's think about how we can generate, say, like part A. So for example, we can connect 2 and 5 together. And then we can connect, say, 3 and 4 together. Then we can append 1 to it. And then we can just append, connect 2, 5, this entire thing with, say, 0. And then we can just connect this entire thing to 0. There's probably other ways to do it too, but yeah, this is just one valid way of doing it. So similarly, if we do this for every single one of these tree, we can also find a valid way to do it. So yeah, basically for part 1, we can simply just select every single one of these configuration. So part 2, for weighted quick union, it's a little bit trickier, but usually the way I think about weighted quick union is that given a tree configuration, right? For every single one of these links that's directly incident to the root node, I would think that these components, they are already its own component before it gets connected to the root node. So what that means is that if we use like part A as an example, if we want to generate something like this, we would need to have 2 and 5 being connected together before it gets connected to 0 in this manner. Reason for that is that if we think of an example of weighted quick union, whenever we establish a link between some node and the root node, this is when we call connect on, say, like this component to this entire component, right? This is the only time when we establish a link in between the actual root node and any other node. So if we think about part A again, this is not possible in weighted quick union because there's no situation where we need to connect 2 nodes or like append it as like the child of the root node, which is only 1 node, right? Because if we connect 2 nodes together to the 3rd node, say 0, just hang out here, what we are going to do is that we're going to connect 0 as the child of 2 because this is a smaller component than this one. So in this case, part A is wrong. So if we keep just like looking at the question using the same method, notice how there is a link from 3 directly to 0 here. So what that means is that this entire thing is already its own component before we connect it to 0. And again, this is not allowed because if we have this like large component here, when we connect it to 0, we shouldn't append 3 as the child of 0 using weighted quick union, right? Instead, we would definitely have something like this, where 0 is pointing to 3 as a child. Okay, moving on, using the same method, since we have a link that points from 5 to 0, we know that 5 is its own component. Similarly, 1 and 3, or the subtree rooted at 1, it's also its own component. The subtree rooted at 2, it's also going to be its own component. So let's just walk through if like the whole procedure and see if it's possible. So basically, let's start from the smallest one. When we connect 0 and 5, right? Imagine having separate 0 and 5. It's definitely possible that we connect them in this way because we're not making any assumption about tie breaking and they're the same size. So we can just assume that we append 5 as the child. So for 1 and 3, imagine like after connecting 0 and 5, since this component is already of size 2, it's also valid to append 1 and 3. directly to the existing component of 0 and 5, because 1 and 3, it's also of size 2, and then the same size as the existing component. So similarly, for this entire component, we know that it's always possible to generate something of this shape because we already analyzed like the first part of the same shape. So yeah, basically, it's definitely valid to just append this entire thing of size 4 directly to the remaining component, because again, they're the same size, and then like, yeah, since we didn't specify tie breaking, it is possible that we just connect it directly to this one. Okay, moving on to D. So yeah, just to make sure that we take a note of it, C is possible. All right, moving on to part D. Again, we can just analyze it in the same way. So we know that these 3 nodes, or the subtree rooted at 2, it's already its own component before connected to 0. 3 is its own component. So let's start with the smaller part. So 3 gets connected to 0 first, and then this entire component of 0 and 3 is of size 2, right? However, if we want to connect the entire other component of size 3 to a component of size 2, we should not be appending size 3 underneath the one with size 2. Instead, it should be the other way around. So yeah, we know that D is also not allowed. Moving on to part E. So yeah, in part E, yeah, let's just do the same thing. So 5 is its own component, 1 and 3 is its own component because it's the subtree rooted at 1. 2, 7, 6 is its own component. Let's start from the smallest one. So let's append 5 to 0. Now we have a component of size 2. That's component 1, 3 to 0, 5. Now we have a component of size 4. And then let's look at this last unit. So this is size 3. And then we have a size 4 right here. So when we connect them, we just append the smaller size one to the larger size one, which is what we see right here. So part E is also valid. Moving on to part F. Part F is actually like a classical example of something that's not possible in weighted quick union. But again, yeah, when we have 3 nodes and then we want to connect it using weighted quick union, it's gonna look like something like this, right? Because imagine if we didn't have any of these links, whenever we union 2 links together, we have a component of size 2. And then if we want to union the last one with the existing component of size 2, it's always going to look like this, and then never something like this. So yeah, this is not allowed. All right, part G. Part G is of a very similar shape as part C. So knowing that part C is valid, we know that it's definitely possible to get something of this shape, right? So in order to obtain part G, we just need to like add a node 8 on top of part C. And then that's definitely doable because node 8 is of size 1. And then when we union 8 with this large component, we definitely do connect it in this way. And then it's what we see here, so it's valid. All right, just to summarize, the ones that we checked are part C, E, and G. Okay, so C, E, and G. All right,